Welcome to Math TV with Professor V. I have another integral of the day for you. I thought we haven't done a definite integral in a little while, so here we go. Definite integral, 0 to pi over 4, x sine x over cosine cubed x dx. All right, if you want to pause the video, give it a try. I'm going to give you a hint that you need to first play around with the trig functions, okay? So I'm going to rewrite this as integral 0 to pi over 4, x I'm going to leave alone. Then I'm going to take sine x, put it over one of the cosine x's, and then I still have two more cosines in the denominator, right? And why do I want to play around with it like that? Well, sine x over cosine x, that's going to become tangent x. What's 1 over cosine squared x? Good, it's secant squared x. And then we still just have lonely little x over here. Okay, great. 0 to pi over 4. So actually, we're pretty much ready to go with integration by parts. So for you, I'm going to let it just be x. And then my dv will be tan x secant squared x dx. All right, let's set it up. So u is going to be x, and then dv is tan x secant squared x dx. And I know this is going to work out because I can already kind of imagine what the antiderivative for tan x secant squared x dx is. We know the derivative of tan x is secant squared x, so I'm going to do a little u sub off to the side, but if you're comfortable, you could probably find v without having to do that and just do this antiderivative in your head, which is fabulous. If not, it's okay. Du would just be dx, right? And then to find v, I'm just going to write a little indefinite integral for now. Tan x secant squared x dx. Now I told you we're going to do a little u sub, but I don't want to use up the variable u because we're doing by parts. So I'll just say let's let t equal tan x. Then dt is secant squared x dx, right? Good. So then from here, I'm going to have integral, t is tan x, and then secant squared x dx is just dt. So this works out to be 1/2 t squared plus c for now, but you know, we don't write the plus c when we do by parts or anything. So 1/2, this will be tan squared x plus c. So now let me rewrite everything. This is what v is without the plus c part. So let's get everybody set up. So u was x, du was dx, dv was tan x secant squared x dx, and then v was just 1/2 tan squared x. Okay, now I'm going to rewrite the integral using our by parts formula. So we have uv. Now remember, this was a definite integral. So when I write u times v, I'm going to write 1/2 x tan squared x, and then you need to put these brackets here to remind yourself that's already anti-differentiated, but it needs to be evaluated from 0 to pi over 4. And then we have minus integral v du. So we have this product right here, v du. Again, let's take that 1/2 outside. I'm going to have 0 to pi over 4, and then this is just tan squared x dx. All right? Very good. Now, how would you proceed to integrate tan squared x? We don't know antiderivative of tan squared, but we're going to use a trig identity. Remember, I can replace tan squared x with secant squared x minus 1. Okay, and then I'm just going to rewrite everything as is. Now, some people start evaluating this at the limits. I like to just kind of wait and do everything at the end, so I'm just going to rewrite it as is right here. Okay, and then we should be ready to go. So I'm going to write 1/2 x tan squared x, no bracket now because I'm going to anti-differentiate the rest of it. Do you see what I'm saying? Minus So look carefully. Antiderivative of secant squared x is tan x. So I have minus 1/2 tan x. And then antiderivative of 1 with respect to x is just going to be x. But I have that minus, and also this minus distributes. So it's going to become plus, very good, 1/2 x. Okay? And then all of this now is going to get evaluated from 0 to pi over 4. So that's why I didn't write this part here, because I knew afterwards I was going to be done. No more integral sign, you see that? So I'm ready to evaluate all of these terms from 0 to pi over 4. So we're going to plug in upper limit first, pi over 4. So we have 1/2 times pi over 4. Tangent of pi over 4 is 1 squared minus 1/2 times tangent of pi over 4 is 1 plus 1/2 times pi over 4, that's the upper limit, minus 1/2 times 0, tangent of 0 is 0, minus 1/2 times 0 plus 1/2 times 0. A lot of zeros going on. What am I left with? This is pi over 8 minus 1/2 plus another pi over 8 minus a bunch of zeros. So I have 2 pi over 8, which is pi over 4 minus 1/2. Okay, so keep in mind when we're evaluating definite integrals are ones that have limits of integration. Your answer is going to be a constant, a numerical value. And we know we can interpret this as the area underneath the curve of the integrand with respect to the x-axis. When you have an indefinite integral, there's no limits of integration, that's when you put plus c at the end. Okay, so it would be wrong to put plus c here. This is not representing a family of functions. Okay, we should have a number, a constant for our answer. So that concludes the video. Hope you found it helpful. Give it a thumbs up. Leave me a comment down below. What was your favorite part? How was this on the spice level of 1 to 10? I would say like the integral I did a couple days ago was a 9, maybe 8 or 9. 8. What is this? 6? 7? You can rate it with a specific chili pepper too. Jalapeno, serrano, I don't know. You tell me. Subscribe if you haven't already. I have full-length video lectures for Calc 1, 2, 3 should you need it. And you can also catch me on Instagram and TikTok, Math TV with Professor V. I'll be back, guys, soon. Bye.